In a factory that produces widgets, it is suspected that the machine that fits the thingies to the widgets is not working properly. The quality control manager thinks about 5% of the thingies are incorrectly fitted. Now we're going to call that a success, this 5%. And that means that for us the probability of success is 0.05, which means the probability of failure is 0.95. She decides to run a batch to find the first incorrectly fitted widget. Find the expected number of correctly fitted thingies before she finds an incorrectly fitted thingy. Well, we have the expectation formula just here. So the expectation of x, where x is the number before we find the first incorrectly one, and we should always define that. I'm not going to write it all down here, but you should define what it is. The expectation of x is 1 take away p divided by p. So that's 1 take away, so we know that p is the probability of success, 0.05. divided by 0.05. So that expectation is going to be 0.95 divided by 0.05 gives us 19. Find the probability that there are 4 correctly fitted thingies before she finds an incorrectly fitted thingy. So what we need here is F, 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 and then success. Now, since x is defined as the number of correctly fitted ones before she finds an incorrectly, as we can see here, we're after the probability that x is equal to 4. So that's going to be 0.95 to the power 4, just following the formula, multiplied by 0.05. So 0.95 to the power 4, and then we're going to multiply that by 0.05. And that's going to give me 0.0407, correct to 4 decimal places. Find the probability that the first incorrectly fitted thingy is the 12th. So, we need 11 failures first, so that's the probability that x is 11. Now clearly we could very easily use the formula, but does the calculator have a feature that enables us to do this? Well, yes it does, but we have to take a bit of care with this. So if we go for the geometric PDF, that means probability density function, that's the one we use when we just want a single value. But if we just come back across to this one, notice if I put x equal to 4 and my probability 0.05, I don't get the same answer. What we have to do on the calculator is we have to state the position of the first actual success. If I calculate that, it is the same answer. So let's use that to work out this one, and obviously we'll have to actually put in that x is 12. So there we go, x is 12, and the probability of success is 0.05, and that gives me 0.02, so 0.0284 if I give the answer to 4 decimal places. So should we just check with a calculation? So that is going to be 0.95 to the power 11, and then multiply that by 0.95, should give us the same answer. And what did we do wrong? 0.05 here. And it is the same answer. Find the probability that there are between 10 and 20 inclusive, so that means 10 is included and 20, correctly fitted thingies before the first incorrectly fitted thingy. So let's think about 10. That's going to give us 10 failures, 0.95 to the 10 multiplied by 0.05. Then we need 11. So that's going to be 0.95 to the 11 multiplied by 0.05. And then we're going to need 12. Now don't worry, I'm not going to sit and calculate all these in the calculator. We're going to have a quick way of doing this. And this needs to continue all the way up to having 20 times 0.05. Now, you should spot that there's a common factor here of 0.95 to the 10 multiplied by 0.05. If we take that out, we end up with 1 plus 0.95 plus 0.95 squared, and so on up to 0.95 to the power 10. And this is a geometric distribution. Sorry, not a geometric distribution, a geometric series. So, if we think about the sum of n terms for a geometric, that's a 1 minus r to the n over 1 minus r. And in this case, there are actually 11 terms. The first term is 1, and the ratio is 0.95. And so on the bottom we've got 1 minus r, which is 0.05. So let's calculate all of this and see what it gives us. So we've got 0.95 to the power 10 multiplied by 0.05 multiplied by 1 take away 0.95 to the power 11 divided by 0.05. Let's calculate that. It gives us 0.2582 if we go to 4 decimal places. Now, can the calculator help us out with this? Well, yes, it can. Interactive, distribution, discrete, but this time we want GeoCDF. That means cumulative distribution function. It will add up a range of values, which is exactly what we want here. So, but just remember, as we did here, we had to go up to 12. It seems to count the success as well, not just the failures on the calculator. So we're going to have to do this as from 11 to 21. And we know our success was 0.05. And this should give us the same answer. And indeed, you can see that it has.